Okay, today we are going to discuss about MOSFET common drain amplifier. This is the circuit diagram for MOSFET common drain amplifier. A common drain MOSFET configuration is also called as source follower. What do you mean by common drain? It's also called as source follower or voltage follower. The future's input signal is applied to the gate. The output is taken from the source and the drain is connected to DC power supply AC ground. That means AC ground. It is voltage gain nearly 1 and the input impedance voltage gain is 1 and input impedance is high. Now the input and the output setup. First you put the signal into the gate terminal, then you can get the output voltage from the source terminal. The drain is directly connected to power supply. Here the drain is directly connected to power supply. It means it is common to both input and output paths for alternating current signal. That means AC signal. Following the input as input voltage at gate goes up, then the transistor lets more current here. Lets more current through the source resistor. Rises the voltage of the source here. Source resistor rises the voltage of the source. The source voltage tries to follow the gate. Source voltage follow the gate closely. Okay, here the gate closely lower by one threshold amount. According to that of phase inversion means there is no phase inversions over the MOSFET. The output wave moves exactly the same direction to that of the input. When the input goes up, the output also goes up. The voltage gain here, is, that means we denoted as AV, is unity. Here we can assign as AV is equal to 1. Okay. According to that of high input impedance. What do you mean by high input impedance? The gate is insulated. The gate is insulated. The current almost zero. Where the current almost zero flows to that of gate terminal. The current almost to that zero flows to that of gate terminal. This means the whole circuit does not load down or disturb the weak sensor. The whole circuit does not disturb the weak sensor. A previous circuit is attached to it. According to here we have completed the high impedance, but now we are going to discuss about the low impedance, low output impedance. According to the impedance, here the source output supply the current. Here source output supplies the current easily to lower the resistance load. Without dropping voltage level. There is no drop on the without dropping voltage level. Okay. Most common uses in the MOSFET common drain amplifier. Voltage buffer. Voltage buffer means voltage buffer used as a middle step here. Middle step used to connect high resistance of the single source to the lower resistance. High resistance of the single source to the lower resistance. What do you mean by impedance matching? Here the function of impedance matching means it prevents the signal. Impedance matching. Impedance matching. Impedance matching means it prevent signal losses. It prevents signal losses. LOSS between where the signal losses it prevents it between the different stage of electronic system. Prevent the signal losses between different stage of electronic system. Where different stage of electronic system, that is the common uses in a common drain amplifier. In common drain amplifier, the input signal is fed to the gate similar to that of the common source amplifier. The output signal is taken from the source terminal. From that we can see here the common door voltage follower circuit. The here input signal we are applying is fed to the gate terminal similar to that of source amplifier. The output is taken from the source terminal. Here load resistance, here R in, here R out, here VDD the power supply, here the input voltage VSS. We are now simplifying the circuit into small signal equivalent circuit of MOSFET source follower like this. Here the small signal circuit is shown as per here. Here the input signal, voltage source, resistance, and here VGS, here GM and VGS R0 for output. Here the load resistance. We can also connect the load resistance over here in the drain. Here the gate terminal and here the source terminal. For according to that of that common drain source follower, the input impedance Vs is equal to 0 and Ig is equal to 0. Input impedance can be written as Rm equal to Rg. Also output impedance Rout is equal to R0 parallel to 1 divided by Gm. This is the output impedance and input impedance of the MOSFET common drain source follower. Then voltage gain. According to that of the voltage gain, the output voltage is given by Vout is equal to Gm VGS, whereas RL the load resistance is parallel to the output resistance. The input voltage is attained by using the voltage divider as VGS is equal to here the VGS already we known as is given by 1 by Gm divided by 1 by Gm plus RL parallel to R0 into V0. This one is modified as V0. Here Gm for V0 we already know that substitute the value of V0 over here. Gm is equal to RL parallel to R0. The multiplication with the VGS value. So from here we can get voltage gain is equal to V0 divided by Vi. Voltage gain is unity. AV is almost 1. As per that of the current gain, output current is equal to R0 divided by R0 plus RL into Gm VGS, whereas RL parallel to R0 is double greater than that of the RL. RL is greater than that of the 1. So RL is equal to 0. We can get now AI is almost equal to RG divided by RL. Therefore AI is equal to, that means current gain, GM and RG. That's all. This is the expression for MOSFET common drain amplifier.